And the interesting thing we saw here was we saw one of the interesting things we saw here was we saw that we could pass a function into a function, right? We passed in dist2d to map. We passed in isNeg to filter. Then we passed in lambda functions as well. So functions are kind of cool in that they are first class Python objects. And in Python, functions can be passed around and assigned and used just like variables or just like values. So we can do this for a lot of other types of problems. Let's take a look quickly at sorting problem. So we've looked at sorting before, and let's say we have a different value for points. We just keep using the same variables and different values, but that's okay. Points is now this, and we know that we can do a sort on points. We know if we sort on points, we can do a sorted on points. And if we do a sorted on points, or we could also do a points.sort, but that would ruin this for the next iteration. If we do a sorted on points, what it'll do is it'll go through our tuples and it'll sort by the x value first. And then when it comes up to a tie on the x value, it'll sort by the y value. So 12.1 comes before 12.3, 12.10 comes after 12.3, 14.10. And if we want to go in the other order, we can do something like reverse equals true. And this will sort it in the opposite order. Right now, we go by the 14, 12, 12, 12. When we have a tie in the x value, then we break it by the y value. Then we come down and finish, kind of finish this up. So we can sort as long as our tuples have, we want to sort by the x coordinate first, and then the y coordinate. Our sort is well set up for doing exactly what we want it to do. So what happens if we don't want to sort by x value? Instead, we want to sort by y value. And now we'll look at our points, and we'll see that our y values are 5, 3, 1, 6, or 5, 3, 1, 5, 10, 10, 12, 3. It turns out that sorted has and sort have this parameter key, so we can do sorted points. We know the reverse equals true. We can also tell it a key, and the key is the thing you want to sort on. And the key can be, well, a function. And in particular, the key can be a lambda function. So let's say we want to sort by the y coordinate instead. We're going to take in a point P. And if we want to sort by y instead of by x, well, the key we want to sort on is this function lambda, and the only thing we need to provide back is, the y value, and the y value is what we want to sort on. And if we do that, well, now we're coming in here and we're saying, okay, 12, 10, 10, 5, 5, 3, 3, 1. And we've now sorted by the y value. Except when we're breaking ties, right, and this is sorting from biggest to smallest, this is okay, right, because 14 is bigger than 12. But we get down here, well, we've sorted by y, but now the smaller x value still comes first. So we want to look at what we can do about that as well. I mentioned a stable sort, and I'm going to tell you that the sorts we use, the sorts that we've discussed with you, are stable sorts. The selection sort, the insert sort, the merge sort, the Python's merge sort, they're all, or the Python sort, sorted, for example, they're all stable sorts. And what that means is, in case of a tie, order is maintained. And if we look at our original points, right, you'll see that that's y, right, 2.5 comes before 6.5, and we had this tie on the 5, and that's the only values we're looking at. So when we have the tie on the 5, the 2.5 stays to the left of the 6.5 because the 2.5 was to the left of the 6.5 in the beginning. So the question is, can we modify this so that this isn't the case, that this is to the right of 6.5 before we get started, and then rely on the fact that this is stable sort to kind of keep this. And you know, if I'm asking the question, then the answer is, of course. And we could do that just by doing a normal sort, right? Normal sort's going to sort by the x coordinates. We'll want to keep our reverse equals true on there so that we maintain the high to low values. And now points x is not sorted by the y coordinate, but we've put this 6.5 and 2.5 in the right relative order, right? And 14.10 and 12.10 remained in the right relative order, etc. So now if we run this on we run our sort on the y coordinate again, but use points x instead, right? Where we've sorted x. Well, now 6.5 and 2.5 were in the right orientation going in, or the right position, right relative positions going in. So coming back out, everything's right, and now we're 12, 10, 10, 14, 12, right? We broke it based on the 14. 5, 5, 6 is here, 2 is here. That's the correct order. 3, 3, 12 is bigger than 5, so that's in the right order. And then we have the 1 again. Okay, so the purpose here is just to show you that there's different ways you can do things. And, since we're using stable sorts, if we do this in a 2-pass arrangement, as long as we put the 6.5 and the 2.5 in the right relative positions, sorting on the y value is enough to get us into sorted order, high to low, y first, and then x. All right. I feel like those TV, as shown on TV promos, because I'm going to say, and now, and that's not all. We got something else we can give you. Let's go back to our original sorted. Right? I haven't used, right? 2 and 5 are in the wrong order because we're using our original points, and points has them in the wrong relative order. But wait, there's more, exactly. This lecture has revolved around doing things in one step, and having to sort these up here ahead of time is kind of annoying. Let's think about what a sort actually does. The sort sorts by the first value first, right? So it sorts by, if we don't have the key specified, it sorts by this value first, and then by this value if there's a tie. Our lambda function is only returning one value, so it never gets to look at this value. So all it's doing is returning this value. This value becomes the first value, and that value is always what's sorted on. But what happens if instead of providing a single value, we provide a tuple, right? And the tuple has a swapped order. So now what we're going to be sorting on is essentially 10, 14, 10, 12, We've just reversed the order of the digits, but we're providing all the digits back to the sorter. At least we're providing the first two values back. And if we do that, that's going to come out exactly like our points x sort: 8, 12, 14, 10, 12, 10, 6, 5, 2, 5, 12, 3, 5, 3, 12, 1. All right? So there we go. There's always multiple ways to do things in computer science. I no longer say there's a best way. I will say there are ways that are more efficient for certain uses than others. This is kind of a cool way of specifying as many sort fields as you need, right? If you just build up a tuple where this is your primary sort key, this is your secondary sort key, tertiary, etc., you can sort on as many fields as you actually want. Let's see what I haven't sorted. Am I done with that. Okay, yeah. This is a fun little... Do we have time for this? How much more do we have in list comprehensions? There's not a lot. See, if we had you guys all in the class, I would have you kind of walk through some of these examples. But this asks us to create a list of words. I'm going to call that W. And we have cow, pig, horse, camel, leopard, and then we'll throw in cat and dog as well. And what the question asks us to do is it asks us to filter out all the words that are shorter than 4 letters from a list of words. So 4 and above we want to keep. Less than 4 we want to throw away. I don't have any that are 4. Let's do bull. Okay, so we want to keep the 4s. We want to keep anything greater than 4. We want to throw out anything less than 4. Okay, and we want to do a lambda function with a filter. So let's generate a list for this one just so we can see it. Lambda function is pretty easy, right? Well, the filter is pretty easy. We start off by typing in filter. That's a function, so we got to give it the function brackets. And now we need a lambda function. And X is going to be our words, our different animals. And what we want to return is a Boolean. So what we want to look at is we want to look at the length of the word, and we want to return true if the length of X is greater than, length of the word is greater than 3. We could also do greater than or equal to 4, right? Both of those are equivalent as long as we're dealing with something finite or something integer like the length of a word. And now what do we want to apply this to? Well, we want to apply it to our list W, right? Filter is the operation. We want to filter based on each one of the words in our list W. And the filter criteria is the length of the word has to be greater than or equal to 4 to be retained. And we want to apply that to our list of animals. And yes, got it, one shot. And we'll actually see that's actually what happens, right? We threw out cow, right? Length of cow is 3, which is not greater than or equal to 4. That would be a false. False, true, 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 false, false, true. All right. See? That's what I said. No typos. Wow. All right. So there's all sorts of uses for these. You know, play with these a little bit. They're actually kind of fun to do. And now we're going to move on to something else. And